Hi, I'm Priscilla, and today we're going to do an experiment to create a perfect laminar flow with balloons. So the material we're going to use are the balloons, the scissors, and the tape. The first step is to fill the balloon with water. I already have the balloon with water, and we're going to do the step 2. So the step 2 is to use the tape for the balloon. So we have to cut the tape in pieces and put them on the balloon to leave a square. Just like that. For the last step, we're going to use a razor or something sharp to break the center of the square. So we're going to cut the center and we will have a perfect laminar flow, as you can see. For this next experiment, I'm going to show you about the superficial tension. For this, I need a coin. This is a regular coin, but I'm going to use this one that is bigger than usual, and this I found it in the house. And the other thing I need is water and a syringe. I only have to introduce the water on it and start putting all the water around the top of the coin. And as you see, the water is staying there, and in a few minutes you are going to see how these start to act. This is usually made with a dropper, but in this case I don't have it, so that's why I'm using this. As you see, the water is going to all the coins, and this making like a dome. But what happens if we put too much water on it? Well, the superficial tension, that is what keep the water on it, is going to break, and the water is going to escape. Continue with the next experiment. Here I had a bowl with water, a piece of paper that is going to simulate a boat, and now I'm going to introduce this to a water with a little soap. So when I put this in the water, it's going to make a superficial tension, and if I put this in the end of the boat, this is going to break the superficial tension, and you're going to see what is going to happen. Introduce in the water. Here is a superficial tension, and then as you see, the boat moves. For this next experiment, I'm going to use a machine. I made this machine, and the only thing I made a base. I put 2 syringes and a tube that is connected. This is basically the represent of the Pascal principle. And for this experiment, to see how this reacts when I put this water, I need some water, and this is color water because I put so it looks a little pink. It looks red. I'm connect this, and the water is going to pass to the tube, and the base is going to go up. It's like an elevator, then goes down and goes up.
My name is Juan Miguel Chávez Muñoz, and in this video I will make an experiment about the Archimedes Principle. So the Archimedes Principle states that the buoyant force of an object will be equal to the total displacement of the fluid in where it floats. So I have this small boat which will float in water. Here I have 2 pieces of tape, which represent the water level at the initial water level. So we can see this small boat floats, and when I put some weight over it, it displaces that amount of water. So it says that the amount of weight I put in this boat will be equal to the amount of water it displaces. So water has nowhere to go, so it goes upwards as long as I make downward force on the small boat.
Hi, today I'm going to make an experiment about the flow rate motion. With this experiment we're going to need 2 bottles, both of the caps, and water. That's all. What you need to do for this experiment, also tape. What you need to do is make a hole through both of the caps and then seal it with tape like this, and that's all. What's this experiment about? We're going to prove, or we're going to see how we can flip this bottle and see what does happen with the water. So, what do you think is going to happen? If I flip this bottle, will the water flow or will it stay? Let's find out. So, let's flip it. And as you can see, the water stays in the upper part. But why does this happen? This happened because in the 2 bottles here is full of air. So this air exerts a pressure. This pressure goes upwards, while this bottle have water, and the water exerts a pressure that goes downwards. So both of the forces touch or connect, so this avoid that the water still flows. But what happens if I hit it a little bit? I don't know if it can be if you can see in the video, but the water starts to flow. Why? Because I'm exerting some extra force. So this air goes upwards and the water goes downwards. That's why it flows. Also, if we make a little vortex, we can see how the water goes and goes and goes. It's going a little bit slow, but this works. And that's basically all the experimental. I hope you enjoyed the video, and thanks for watching.